Hey, I'm Vaughn Stewart with NetApp. Here at VMworld 2013 in San Francisco. Great show. This year, of course, VMware is delivering all the goods, helping us to advance our data centers and our cloud initiatives. There's so much to share that I would love to cover the whole show for everyone, but I'd like to maybe focus a little bit around what NetApp's initiatives are and what we're helping to bring to our customers as they move forward. So, big talking points this year, one of them being software-defined data centers. What does this mean? And furthermore, how does storage work within this type of construct? From our perspective, we look at a software-defined data center as this initiative to virtualize the entire infrastructure stack, to help customers be able to drive greater agility in the delivery of IT services to their application owners as well as to their development teams. In support of this initiative, NetApp has a software-defined storage strategy that's really kind of based on three pillars. And then these technologies are surrounded by, or I should say provided by, our latest advancements in cluster data Ontap. So as we look to help move this forward, here's the summary of our architectural design model. First, we look at providing virtualized storage services. Second, we want customers to be able to provide this capability on a plethora of platforms, whether it's NetApp hardware, third-party, local disk drives inside of a server or in the cloud. And fourth, which is the end goal of our solution or strategy in an alignment with software-defined data centers, is to really provide self-service or autonomy to application owners and development teams. So now let me take each of these three pillars, if you will, virtualized storage services, platform flexibility, and application self-service, and speak to them in a little bit greater depth. With cluster data Ontap, this is the next generation of our #1 storage operating system, data Ontap, and it provides two major initiatives within the platform. First, it supports a scale-out architecture, moving storage controllers from the 2-node configuration that most of you are used to up to a 24-node scale-out cluster. This is a scale-out cluster that has storage efficiencies built into it, so it allows an enterprise to be both responsive to their data center constraints, but is also to be able to scale the storage infrastructure without having to introduce downtime or outages. On top of, or as a part of this cluster, we've now moved the access point away from physical storage devices and now have a new storage construct called a storage virtual machine. This is a logical storage controller that can be comprised of storage resources from part of one storage controller or can consume resources from all 24 nodes in the cluster. The ability of a storage virtual machine allows storage resources to be assigned, reassigned, on demand, all non-disruptively from the application or end users that receive their services from the storage VM. As the storage VM is defined in software, it allows us then to deliver storage services through policies and service levels. Thus, whether I need a NAS file system or a block-based LUN that could be iSCSI or Fiber Channel or SMB or NFS, these are just service offerings that are available to the storage VM. These service offerings are then enhanced by performance levels in terms of the storage performance requirements, storage capacity settings and thresholds, as well as data protection levels. The beauty of all of these services is because they're defined in software, they can be adjusted on the fly, non-disruptively at any time, and because they are abstracted from the hardware, it allows the storage administrator to manage the hardware infrastructure independent from the service level that's being provided for each application. By having a storage infrastructure that can have multiple storage VMs, I can truly have a shared storage infrastructure that leverages the economics of scale and standardization in terms of data management, while also allowing each operational or organizational team to have what they believe to be their own virtualized storage controller. Backing the storage VMs and what helps a storage admin carve up their services is a robust role-based access capability so that each storage VM can have a different set of capabilities based on the needs of the application team. For example, someone who's providing Windows Home Directory services needs a different set of capabilities, such as the ability to create shares and grow storage, than what, say, someone who's running a virtual desktop infrastructure. And that's someone who may make new desktop pools all the time and destroy old desktop pools. I probably don't want to let a Windows share admin accidentally delete their data, because replacing petabytes of data can be quite painful. But that is a critical capability that someone needs to say in the virtual desktop space. So RBAC is one key element to providing a storage virtual machine. Beyond RBAC is a rich and robust quality of service capability. As storage platforms continue to drive more flash technologies into the arrays become more resilient to unexpected changes in workload. It also means that the ability of the array to burst to higher levels of performance is capable. And you never want some rogue system, backup operation, big data processing to take over your array and have a negative impact on other applications. So robust quality of service controls, both in the frameworks of reporting but also enforcing limits, allow us to apply tiers to files, volumes, or LUNs. And this means both physical systems, NAS file services, or in the capability of putting QoS on files, virtual machines and databases can have greater granularity and control. The storage admin receives a benefit by understanding what's occurring across the board in the storage array, what is it subscribed to, how much is the oversubscribed, are they comfortable with that? They get a better guidance on knowing what resources they need to provide to the infrastructure. But furthermore, they know that no one can go rogue within the infrastructure and put an overwhelming load on the storage subsystem. That is all comprised within the virtualized storage services. That is the external component of the storage controller. Beyond that, these virtualized storage services, the RBAC, the QoS, etc., can all be provided on both NetApp hardware and inside of the FlexPod, but it can also run on third-party hardware storage arrays like those from EMC or HP, Dell, etc. Can also run on servers and their local disk through our Data Ontap Edge, which is our virtual storage appliance, which is powered by VMware vSphere. It can also run in the cloud in the format of NetApp Private Storage for AWS. The beauty of this model is the consistency and capabilities is standardized across every deployment model. And so now customers can deploy within their data centers, can drive new value into existing storage purchases, can now enable new remote and even mobile data centers through Data Ontap Edge, or can now start to build a hybrid cloud model that connects both their data center to a partner like Amazon AWS and have control of their data and be able to deliver a seamless application integration, whether it's running on-premise or in the cloud. This choice and flexibility is really a big driver for a lot of our customers who are looking at new ways to scale out their infrastructure and do so in a cost-effective manner. And so choice and standardization is a key enablement here. Going beyond the two pillars, virtualized storage services and platform flexibility, kind of comes back to the crux of what a software-defined data center is, and we call this application self-service. Through Data Ontap, customers receive a standardized programmable set of APIs that are hardware independent and work in all the previous deployment models. These APIs can operate both at the storage controller layer for storage management, but also at the SVM layer, and can be driven directly into infrastructure application tools such as inside of VMware infrastructure or OpenStack, as well as up all the way into the application layer, be it Oracle, SAP, Microsoft applications, etc. A fun fact that many might not know, but in 2012, NetApp was selected as Microsoft's Server Platform Partner of the Year. A storage vendor was selected as the Server Platform Partner of the Year for these reasons specifically, for what we do to enable greater integration between the server and application plane and the storage plane. And we do these through our application integrations within Microsoft System Center, Microsoft System Center Orchestrator, as well as SQL Server, Exchange, SharePoint, and more. We have a very robust set of PowerShell APIs that are available for those who want to build their own tools and draw that back into Data Ontap. Speaking specifically about VMware and VMware infrastructure integrations, NetApp obviously supports all the vStorage APIs, the VASA provider, the VDP for data protection, as well as we are showing in our booth here our capabilities around the next generation VMware vVols that we hope will ship in a future release of vSphere. NetApp's vVol development is so far ahead of schedule that with Data Ontap 8.2.1, which will release here in just a couple of weeks, we will actually certify that code as GA for vVols in anticipation of this release from VMware vSphere. In our staying on VMware, we talk more about infrastructure automation. We also have a robust set of plugins, both for vCenter automation, as well as a plugin for vCenter Orchestrator, which then powers orchestration underneath VMware VCAC. And if for those who are looking to go beyond VCAC and look at OpenStack, the NetApp Cinder driver works very well in terms of being able to provide a set of storage services in support of the Nova or the compute stack inside of OpenStack, and of course that supports vSphere as well as the rest of our hypervisor or virtualization partners such as Microsoft, Citrix, and Red Hat. This infrastructure and application self-service is really kind of the future that helps bridge the gap and gives storage services much more dynamic capabilities that are in line with what many of us are familiar with from VMware in terms of the virtualized compute layer. These services come together and form the foundation for NetApp's software-defined storage offering. Virtualized storage services, platform flexibility, and application self-service through open and programmable APIs is how we view moving the infrastructure forward. All this is possible within Cluster Data ONTAP, and Cluster Data ONTAP carries forward the NetApp legacy around driving customers faster, providing standardized storage services that are also driven by storage efficiencies and powered by flash technologies. This is Vaughn Stewart. It's been a long day here at VMworld. In fact, it's been a long week. The NetApp team has done a fantastic job delivering their demos for the booth. If you haven't stopped by and check it out. If you've missed it, check out on YouTube, because soon we'll have all these demos available for you online. Thanks for the time and watching. I appreciate it. Cheers.